Introduction to Database Management System. A database management system, DBMS, is a software application that allows users to create, store, organize, and manipulate data in databases. DBMS provides a structured approach to data management, ensuring data consistency, security, and efficiency. Examples of popular DBMS include MySQL, Oracle, and Microsoft SQL Server. Example: a college uses a DBMS to store student information such as names, addresses, and grades, making it easier to manage and retrieve the data. Data points. DBMS improves data integrity by enforcing data constraints, supports data backup and recovery, and allows simultaneous access by multiple users. Advantages of using a DBMS. Improved data sharing. DBMS enables multiple users to access and share data concurrently, increasing collaboration and efficiency. Data integrity and security. DBMS provides mechanisms to ensure data is accurate and protected from unauthorized access or loss. Reduced data redundancy. With a DBMS, data is centralized, reducing the duplication of information and minimizing data inconsistencies. Types of database models. Relational databases. Organize data into tables with predefined relationships, allowing for efficient data manipulation and query processing. Hierarchical databases. Structure data in a parent-child relationship, where each child has only one parent, suitable for representing a hierarchy. Network databases. Similar to hierarchical databases, but with the ability to represent multiple parent-child relationships, enabling complex data structures. SQL and database queries. SQL, Structured Query Language, is a standardized language used for managing and querying databases. Select statement retrieves data from one or more tables based on specified conditions. Update statement modifies existing data in a table based on specified conditions. Join statement combines rows from different tables based on a related column, allowing for more complex queries. Data normalization. Data normalization is the process of organizing data in a database to minimize redundancy and dependency issues. First normal form, 1NF, ensures that each column contains only atomic values and there are no repeating groups. Second normal form, 2NF, builds upon 1NF by ensuring that non-key attributes rely solely on the entire primary key. Third normal form, 3NF, extends 2NF by ensuring that non-key attributes do not depend on other non-key attributes. Some key features of DBMS include 1. Data storage. 2. Data retrieval. 3. Data manipulation. 4. Data security. 5. Data consistency. 6. Data backup and recovery. Database querying. Database querying involves retrieving information from databases using queries. Queries are written in SQL, a standard language for interacting with databases. DBMS processes queries and returns the requested data based on specified conditions. Example: select asterisk from students where major computer science retrieves all students who have declared computer science as their major. Data points. Query optimization techniques, such as indexing and query caching, enhance the efficiency of query processing. Database security. User authentication ensures that only authorized individuals can access the database, typically through username and password. Access control grants or restricts users' privileges, allowing them to perform specific operations on the database. Encryption protects sensitive data by transforming it into an unreadable format, requiring decryption to access the original information. Database backup and recovery. Regular data backups are essential to prevent data loss due to software failures, hardware issues, or unforeseen events. Full backup copies all data in the database to an external storage device, providing complete recovery in case of data loss. Incremental backup only backs up the changes made since the last backup, reducing storage space and backup time. Database performance tuning. Database performance tuning aims to optimize the efficiency and responsiveness of a database system. Techniques such as index optimization, query optimization, and database configuration adjustments are used. Monitoring tools help identify bottlenecks and performance issues, allowing for proactive performance improvements. Example: by creating appropriate indexes and optimizing queries, the college database can deliver faster response times for student registration processes. Data points. Performance tuning methodologies include query rewriting, caching, and server parameter tuning for better resource allocation. Future trends in DBMS. Big data. DBMS is evolving to handle massive volumes of structured and unstructured data, enabling advanced analytics and insights. Cloud-based databases. DBMS are increasingly moving to the cloud, providing scalability, accessibility, and cost savings. NoSQL databases. Non-relational databases, such as MongoDB and Cassandra, are gaining popularity for their flexibility and scalability. Conclusion. Database management systems are essential for effectively managing and manipulating data. College students can benefit from understanding DBMS concepts and their applications in various industries. Learning about DBMS provides valuable skills for future employment opportunities. Example, companies across sectors rely on DBMS to handle large volumes of data, leading to increased demand for professionals with DBMS expertise. Data points. The usage of MongoDB, Oracle, MySQL, and other popular DBMS solutions highlights the wide adoption of such systems.